Hey everyone, welcome back to another CIE A Level Maths past paper video. Today we're going to talk about paper 3-2 from the October-November 2025 series. So let's jump into the paper. Question number 1. Sketch the graph of y equals to x plus 3a where a is a positive constant. Okay, so recall from our revision videos how to split this into a piecewise function. So this could be rewritten as x plus 3a and minus x plus 3a. So one range would be just make x plus 3a equal to 0 or less than 0. So for example, what I'm saying is we need to figure out where it goes less than 0. So that would be less than negative 3a. So this would be the range for this one, and this would be the range for this one. Since a is a positive constant, that means negative 3a would be on the negative side. So alright, let's sketch the graph now. This graph, you see 3a is also our y-intercept. Okay, so 3a is also our y-intercept and the x-intercept. So this will go like this. Now, on the other side, like the other part of the graph, it has to be, let's use a different color, symmetric. So basically what we want and for example, let's go slightly down, right? Okay, so that means at 5a, it should be crossing, oh no, sorry, no. Like this. So basically what I wanted to do over here was that at 5a it should be crossing the 2a. Symmetric graph over here. Okay? So yeah, so basically let's just finish it. This would be, oh no, sorry. This is your y-axis, this is your x-axis. Okay? And we don't need these dotted lines anymore. Okay? Right. Hence or otherwise, solve the inequality x plus 3a greater than a minus 2x. Okay, so notice over here that this line has a greater gradient than our line. So a minus 2x, it will pass from a, but its gradient would be greater than this one. So just as right, so it will be somewhat like this. 2x. You see, 2x would mean at half of a, it's going a. So rise over run, doubled. So what we see over here is that there's only one point of intersection. So if we want to figure out where this particular graph, our V graph, is greater than the a minus 2x, it's basically this part. Okay, beyond this point of intersection. So this is our x plus 3a, right? And this is our a minus 2x. So basically, we just need to equate them. Okay, that's all we need to do. So x plus 3a equals to a minus 2x. We will get 3x equals to a minus 3a and equals to negative 2a. So x is equal to negative 2/3 of a. Okay, so this is the critical point of it here, point of intersection. Hence the range is x greater than negative 2/3 of a. That's it. Okay? Alright, so that's it for this question. Let's move on to the next one. Question number 2. Solve the equation 3 times by 2x plus 1, 4 times by 3, 2x minus 3. Now multiple ways to solve this one, not just one way to do that. So you can take ln on both sides, or you can simplify this first also. Either way, that's your choice. So you have 2x plus 1 divided by 4 equals to 2x minus 3 divided by 3. Now see how this can be simplified. 4 is basically 2 squared. So 2x plus 1 minus 2 equals to 2x minus 3 minus 1. So this becomes 2x minus 1 equals to 2x minus 4. Okay, carefully. Now we take the ln on both sides. So ln of 2x minus 1 equals to ln of 2x minus 4. X minus 1 comes down. This becomes ln of 2. Similarly, 2x minus 4, ln of 3. Multiply the ln 2 inside. So x ln 2 minus ln 2. 2x ln 3 minus 4 ln 3. We bring all the x terms on one side. So this would be 2x ln 3 minus x ln 2 equals to 4 ln 3 minus ln 2. Okay, so factorize out x. This would be 2 ln 3 minus ln 2, 4 ln 3 minus ln 2, and finally this would be 4 ln 3 minus ln 2 divided by 2 ln 3 minus ln 2. Now we need the answer. So 4 ln 3 minus ln 2 divided by 2 ln 3 minus ln 2. So you get 2.46 to 3 significant figures. Okay. Alright. Okay. Now let's move on. Question number 3. The shaded region in the Argand diagram bounded by a line and a circle represents the complex number satisfying the real z less than equal to 2 and z minus 3i. So basically this is, for example, can also be written as x less than equal to 2, basically this line, and this is the circle equation, and the less than equal to 2 means all the points inside and on the circle. The point P showed on the diagram is one of the points of intersection of the line and the circle. Find the complex number represented by the point. Okay. So if we convert them into Cartesian form, so real z can be less than equal to 2 can be written as x less than equal to 2. Okay, and this thing z minus 3 plus I less than equal to 2 can be written as x minus 3 whole squared, plus y minus 1 whole squared equals to 2, or less than equal to 2 basically. Okay, so at P, x is equal to 2 and x minus 3 whole squared plus y minus 1 whole squared is also equal to, 4. This would be 4 because it's r squared. Now, since x is equal to 2 at P, we will just plug in 2 over here. So 2 minus 3 whole squared plus y minus 1 whole squared is equal to 4. This would be 1 basically. So y minus 1 whole squared is equal to 4 minus 1, 3. This would become y minus 1 is equal to plus minus root 3, and therefore y would be 1 plus minus root 3. So therefore at P, x is equal to 2, y equals to 1 minus root 3, just to confirm that this is going to be the same number. Negative? Yes, okay. So z would be 2 plus 1 minus root 3 I. Okay. Now find the greatest value of argument of z for the points in the shaded region. Okay. So greatest value for the argument z. So basically you notice that either it's going to be this or it's going to be somewhere over here, and it's not going to be P. This point is not P. So basically this. Okay. So greatest argument would be basically, we can visually see that this is the one, but we can actually do some working to figure this one out also. So what do we know of this point up till now? So we know that this is the radius, and this radius is 2, right? And okay. We know the distance to this center, right? We also know the distance to the center, 3 and 1. So 3 squared plus 1 squared is equal to 9 plus 1, 10. So square root of 10. Okay. Square root of 10. And this is your 2. And this is a right angle triangle. Okay. So we can find out this angle, this part of the angle, but not this part. So this part we can actually get from this thing. So this is 1 and this is 3. Right, so let's call it theta, let's call it alpha. Okay, so argument of z, greatest argument, will come from sine inverse of 2 over root 10 plus tan inverse of 1 over 3. Yeah, 1 over 3. Okay, just to make sure that this angle opposite is opposite is 2, hypotenuse is 10, that means this is a sine, and this is 1, 3, tan. Okay, and that would be it. So that's all what we want. So sine inverse of 2 divided by square root 10 plus tan inverse of 1 divided by 3. So radians 1.01 radians. That's it. Alright, so let's move on to the next question. Okay, so question number 4. Find the exact value of the integral of x tan inverse of x, limit 0 to 1. Alright. So this will be handled using integration by parts. So 0, 1, x tan inverse of x dx will be handled with integration by parts. So basically we need the u and v basically first, right? So we know the Eilert rule or the Leiter rule. Tan inverse would be the inverse I, and the x is basically the algebraic component. So u is preferred to be tan inverse. So u is tan inverse of x. Therefore u prime would be 1 over 1 plus x squared. If you forget, you can just simply see from the formula booklet. Similarly, v is x. So therefore the integral of v dx would be x squared over 2. Now when we are actually doing the integral u integral v dx minus u prime integral v dx dx, notice what two terms will be actually multiplying. This one and this one. So we might need to deal with them before we go on. So when you have x squared over 1 plus x squared, we can't integrate them as it is. We need to do some partial fractions over here. So just not partial fractions, a simple long division. So 1 plus x squared x squared. So when you multiply this by 1, you get x squared plus 1 minus this becomes minus 1. Right, that's it. So is equal to 1 minus 1 over 1 plus x squared. That's it. That's all we need. So when we plug it in, so half of x squared tan inverse of x minus integral of half, because you see x squared over 2, 1 minus 1 over 1 plus x squared dx. So the limits are from 0 to 1. This remains as it is, half x squared tan inverse of x minus half. This becomes x minus, this becomes tan inverse simply of x, right? So we can write it as 1 over 2x, and this is 1 over 2 tan inverse of x, 0 to 1. Now we plug in the limits. So half times by 1 times by tan inverse of 1 minus half of 1 minus half of tan inverse of 1 minus half of 0 half of 0 minus tan inverse of 0 is also 0. Okay, so you get tan inverse of 1 is pi by 4. Pi by 4 times by 2. This would be pi by 8 minus 1 over 2. The minus minus will actually make it plus, no? Yeah, minus minus would actually make it plus. Even minus over here, right? So this would also be pi by 8. So pi by 8 plus pi by 8 is pi by 4 minus 1 over 2. That's our final answer. Okay. And we needed this in exact form? Yes, exact form. That's it. Alright, so let's move on. Question number 5. It is given that f of x is equal to x minus a squared g of x, where f of x and g of x are polynomials. Show that x minus a is a factor of f inverse of x. Alright, so what we can do now is we can differentiate this using the product rule, right? So f inverse of x would be x minus a whole squared g prime of x plus 2x minus a g of x, right? So you can factorize out x minus a. So x minus a g of x. So let's use it bigger. G of x plus 2 g of x. Okay, so you can like multiply it over the brackets also. So x minus a. This would become x g of x minus a g of x plus 2 g of x. So this would become, we don't actually have to simplify this quite that much, so x minus a plus 2. Right, okay, so since x minus a is a factor, you see that is basically, hence x minus a is a factor of oh sorry, no, this one was g prime. Oh sorry, I forgot, this is g prime, so we can't actually do this now. Right, this line can't exist. Yeah, is a factor, but the rest is fine. So this one was g prime, the derivative of g basically. Two x minus a gx. Right, okay. It is given that x minus 3 whole squared is a factor of this thing. Find the values of p and q. So we're going to use this rule over here, right? Is a factor of this. Actually over here you could also do the factor rule over here. So f prime of a would be 0. So hence that would be also the case. But okay, so hence x is given that x minus 3 whole squared is a factor of this thing. So over here they had us use, so basically over here x minus a squared is a factor of f of x. So basically what if we mimic this, 4x squared plus px plus q is equal to x minus 3 whole squared g of x. Using this rule over here, x minus 3 is a factor of derivative of this thing. 3 times by 2, 6x squared minus 8x plus p. Okay, so that means that let's call it f prime of x. Okay, so f of x is equal to x minus 3 whole squared g of x. F prime of x, 3 times by 2, 6x squared minus 8x plus p. Alright, so when we plug in f prime of 3, we get 6 times by 3 squared minus 8 times by 3 plus p equal to 0. 6 times by 9, 54. 8 times by 3, 24 plus p equal to 0. Therefore, p is equal to minus 54 plus 24. So basically 30. Right? Now for q. So q can also be found by doing the right. So since x minus 3 whole squared is a factor of f of x, then that means f of 3 would also be 0. So you have 2, 3 cubed minus 4, 3 squared, plus p, that is minus 30, 3 plus q equal to 0. So 2 times by 27, 54, minus 4 times by 9, 36, 90 plus q equal to 0. So therefore q is minus 54 plus 36 plus 90. So minus 54 plus 36 plus 90, that is 72. Alright, so p is negative 30, q is 72. Alright, so let's look at question number 6. By sketching a suitable pair of graphs, show that the equation cot 2x is equal to 2 sine 2x minus 1 has exactly one root in the interval 0 to pi by 2. Right, okay, so the suitable pair of graphs that we need to make, one is cot 2x and the other is 2 sine 2x. So cot x goes like this. Usually this asymptote is at pi, but since this period is halved, it would be at pi by 2. Okay. Similarly, 2 sine 2x, it would be going somewhat like this, where the mean position is at minus 1, the maximum is at 2 minus 1, and minus 2 minus 1 minus 3. Alright, so we just have to combine these. Alright, so let's draw them together. Let's choose a thinner line. Okay. Okay. We can use the ruler to help set up. So 1, 2, 3,
4, 5, and okay. So 1, 2, 3, 4, 5, 6, 7. Right, okay. Now, where do we need the asymptotes? Oh, sorry, just the grid lines, just for guidance lines basically. So at 1, a little thinner, this, at -1, and at 3, right? And we also need some vertical ones also. Okay, so we need it at pi by 4 and at pi by 2. Right, okay, so just to make sure that the graphs are labeled, the units are labeled, this is your 1, 2, 3, -1, -2, -3. This is pi by 4, and this is your pi by 2. Alright, okay. So first let's sketch the chord graph. Chord graph is actually coming from this side, passing through this. So no. Okay, and it will continue going. Right, so somewhat like this. But the sine graph, I'll use a different, okay, no, same color. It's going to go from -1 to over here. Right, okay, so we just right, and that's about it. Okay, so why it just comes back at pi by 2? Because sine graph actually goes this way. So usually this point is pi, but since the period is halved, this would be pi by 2 instead. Okay, so now we just need to label it. This is your cot 2x, and this is your what was it? Yeah, 2 sine 2x -1. Okay, now it's up to your, like, since you'll be actually doing this at using your pencil, you can make it sort of less thick. Okay, or you can remove them also. That's your particular choice, but we still have to, like, justify why we think there's only one root. So we can say, right, because we have to, like, we just need to show. So the reason being, there's only one point of intersection. So only one point of intersection exists between y equals to cot 2x and y equals to 2 sine 2x -1. Hence, only one root exists in this range, in the range 0 to pi by 2. Right, okay. Show by calculation that this root is in the interval 0.4 to 0.6. So basically we just need to show some change in sign. So first off, we need to write it as a function cot 2x. Since this is 2 sine 2x minus 1, when you subtract it on the other side, this will become minus 2 sine 2x plus 1. Alright, so we just need to show 0.4 and f of 0.6. Okay. So cot is basically 1 over tan 2 times by 0.4 minus 2 times by sine of 2 times by 0.4 plus 1. So this one is 0.536 and at 0.6 it is 4,753. So sine is changing in this range. That means sine changes from x is equal to 0.4 to x is equal to 0.6. Hence, therefore you can say, therefore root lies over here in 0.4 to 0.6. Now use the iterative formula to calculate the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Now notice over here one thing, that these values might seem small, but there is actually a huge difference between them. So what we can do is we can narrow this range down further by using bisection of the range. So we can divide the range from 0.4 to, write in 0.4 to 0.5. That means just simply bisecting the range, and 0.5 to 0.6. Then we conduct the same experiment and see whether which range would actually give us change of sign better. So this will narrow our search a little bit. So we know from 0.4 we need 0.5, and 0.5 would be minus 0.040. Okay, that means the sign is changing in between this, right? So sign is not going to change in this, sign is changing over here. Alright, so that means we can start from 0.5 instead, because at 0.5 it's closer to 0. Okay, you can even further go down. Alright, so you can even further go down. You can bisect the range even further. So you can go from 0.4, since you have already bisected it this way. Now the difference between the starting point and the end point is 0.1, so you can do 0.1 divided by 2, so 0.5 to 0.50. Okay, so now we test out this thing, and if it gives us what I'm hoping it will tell us, yeah, right, so 0.45 is 0.226, and 0.5 is actually already this. So that means now we have a better range, or better values, slightly better values to start with. So either you can start with 0.5, you can start with 0.45 also. Even you can bisect this range further. However, I think it's pretty fine that we either start with 0.5 or 0.45, because we have narrowed the search a little bit. So for example, we start with 0.5. Okay, so x2. Alright, now we need to use this range basically. Okay, so 0.5 times by tan inverse of 1 divided by 2 sine 2x to, I think I should have written should have saved 0.5 first. Okay, we'll do that later on. Minus 1. So this is 0.4858. Okay, so I save this one first, and instead of 0.5 I plug in answer. So the next one is 0.4967. Right. Now we have 0.488, 3, 0.4947, and right, x6 0.4897, 98 you can say. As you can see, up to 2 decimal places the numbers are going to be like constant. So up to 2 decimal places it's still 0.49. So we are just making sure that we are in the same range. So 0.4935. So that's it. So if you notice, to 2 decimal places, if you round these numbers, okay, so it's in between 0.49. So hence, or you can say therefore, x is equal to 0.49. Right, okay. Let's move on to the next question. The equation of the curve is this. Show that dy by dx is this. Alright, so this is easy. This is implicit differentiation. So dy by dx of 2y cubed minus 3x squared y minus x cubed equals to d by dx of 16. So this would be 3 times by 2, 6y squared dy by dx minus, this time for this one you have to use the product rule over here. So 3x squared dy by dx, and then plus 6x times 6xy, right? So this time, like 3x, you can use u as 3x squared, u prime would be 6x, y is, v is y, so v prime is dy by dx. That's exactly what we did over here. And minus 3x squared equal to 0. You can multiply them, like you can distribute the minus inside. So dy by dx, you have 6y squared minus 3x squared, and on the other side you take away all the terms, so 3x squared plus 6xy, because you see minus is already going to turn this negative on the left hand side. On the right hand side this would be positive. So now we just divide. So 3x squared plus 6xy divided by 6y squared minus 3x squared. Now we see all the terms are divisible by 3, so this would lead to x squared plus 2xy divided by 2y squared minus x squared. And that's exactly what we had over here. Okay, alright. Hence find the coordinates of the points on the curve at which the normal is parallel to y-axis. So normal, not tangent. Okay. If they say normal is parallel to y-axis, that means the tangent is parallel to x-axis. Tangent is parallel to x-axis. So you can write over here, so if normal, or when normal is parallel to y-axis, then tangent is parallel to x-axis. That means, basically means dy by dx 0. Okay, so we need to find dy by dx being equal to 0. So x squared plus 2xy to y squared minus x squared equal to 0. So the denominator basically just simply goes away because you cross multiply with 0. This becomes x squared plus 2xy equal to 0, at which the normal is parallel to y-axis. Okay, so factorize this out. So either this becomes x plus 2y equal to 0. So either it is when x is equal to 0 or when 2y, or x is minus 2y. Okay, so basically we can plug this over here to figure this out. Okay. So first we plug in x at x is equal to 0. You have 2y cubed is equals to 16. Okay, so all the x terms will be 0, so 2y cubed equals to 16. So that means y cubed would be 8. Therefore that means y would be 2. So this becomes into x is equal to 0, y equals to 2. That's 16 or minus 16? 16. Okay, 2y cubed. Okay. Now when x is minus 2y, so we have to plug in that. So 2y cubed, 3x squared y, yeah, minus 3x squared y, 3x squared y, then we have minus x cubed equal to 16. Minus x cubed, no? So minus 2y cubed equals to 16. Alright, so let's figure this out. So you have 2y cubed. The square of 2y negative would be just 4y whole squared. So minus 3 4y whole squared times by y minus, this would be minus 8y cubed equals to 16, because negative 2y whole cubed would still be negative, right? So this one would become 2y cubed minus 12y cubed plus 8y cubed equals to 16. So 2 minus 12 minus 10 plus 2 is just minus 2y cubed equal to 16. So y cubed is equal to minus 8. So hence you're getting y equals to minus 2. So therefore x would be minus 2 times by that. So that would be just 4. So points of, so the necessary coordinates are minus 2, sorry, no, 4, minus 2, and 0, 2. Right, okay, let's move on to the next question. To prove the identity, sine 4x equals to 4 sine x times by 2 cos cubed x minus cos x. So, alright, so let's start with the right hand side. Okay, so when you have 4 sine x, you can factorize out cos x over here. Cos x, this would become 2 cos squared x minus 1, right? On this side, if you separate out 2 sine x, cos x, and then multiply this with 2 times by 2 cos squared x minus 1, just to like separate out that. So this one is sine 2x. This remains as it is, and this is your cos 2x. Yeah, right. So basically this is 2 sine 2x cos 2x, which is identical to sine 4x. Okay, double angle identity basically, hence shown basically. Hence sine 4x is identical to that thing, 4 sine x, 2 cos cubed x minus cos of x. Right, okay, that's it, done. Now hence find the exact value of cos cubed x sine 4x. Wait. Cos cubed x 4 sine 4x. Okay, so basically we have to use this thing for sine 4x. So you have the function integral of cos cubed x times by 4 sine x times by 2 cos cubed x minus cos of x dx. Right, just to make sure this was 4 sine x, 2 cos cubed x minus cos x. Okay. Right, so let's simplify this before we go on. So this is 4 times by 2 sine x cos raised to power 6x, and then you have 4 sine x cos raised to power 4x, right? One power is 6, the other is 4 dx. Okay, alright, so I think this is straightforward now, not a big deal. So we'll take this one as the powered function. The derivative of cosine basically is minus sign, right? So if you multiply a minus over here, just to like do that, that will be very easy. In this you can integrate it separately even. So this would become minus 8. Yeah, alright, okay. So basically what I'm trying to show over here, that the derivative of cosine basically is that, right? So if you substitute cos x with, for example, u, if u is equal to cos of x, du over dx would be minus sine of x, right? So therefore du would be minus sine of x dx. So minus sine of x dx entirely will be chosen as the du. So this would be basically just to show you with one way, this is going to be 8u du, simply 8u raised to power 6, sorry, du minus a, this is going to be also handled same way. So minus is already there, so we can make it minus minus also, plus negative because the sign is already chosen. So you have 4 u raised to power 4 du. Okay, now it's up to you. Basically you can like keep it in the sine cos format also. So this would one become minus 8 cos raised to power 7x over 7 plus 4 cos raised to power 5x over 5 in between 0 to pi by 4. Alright, and now we just plug in the limits. So you have minus 8 over 7. Cos of pi by 4 is basically 1 over root 2 or under root 2 by 2 raised to power 7 plus 4 over 5 cos of under root 2 over 2 raised to power 5 minus cos of 0 is 1, basically 8 over 7, and once again cos of 0 is 1. Okay, so under root 2 divided by 2, we save it like this. So minus 8 times by answer divided by 7. No. Minus 8 divided by 7 times by answer raised to power 7 plus 4 divided by 5 times by answer raised to power 5. Then you have plus 8 divided by 7 and minus 4 divided by 5. Okay. We need the exact value. Right. So that's it. That will be your exact value. So 12 plus root 2 divided by 35. Now, if you want to do this manually, we can do this manually also. Okay, so we can do this manually also. So let's do this manually. So root 2 raised to power 7 can be written as 2 7 over 2, and similarly root 2 5 raised to power 5 can be written as 2 5 over 2. So this one would become minus 8 over 7, 2 raised to power 7 over 2 minus 1. No, wait. Technically this is just 1 over root 2 now. So 2 raised to power minus 1 over 2. So 2 raised to power minus 7 over 2 and plus 4 over 5, and also the same thing, 2 raised to power minus 5 over 2 plus 8 over 7 minus 4 over 5. Okay. Furthermore, 2 raised to power 7 is 128 and 2 raised to power 5 is 32. And so 7 over 2 can also be written as 3.5 now. So like 2 raised to power 7 over 2 can also be written as 2 raised to power 3, 2 raised to power 1 over 2. So 8 root 2 also, right? So minus 8 over 7 can, and this is 3.5, so 8 root 2 plus 4 over 5, and also this thing, 2 raised to power 2, 4 root 2 plus 8 over 7 minus 4 over 5. Now as you can see, the 8 and 4 and 4 can get cancelled. So what else? So you have minus 1 over 7 root 2 plus 1 over 5 root 2 plus 8 over 7 minus 4 over 5. Now it's up to you how you can actually handle this. You can further go with root 2 like that. So minus root 2 over 14, 7 times by 2, and this one would become root 2 over 10 plus 8 over 7 minus 4 over 5. So if you check now, minus 1 divided by 14 plus 1 divided by 10 is 1 over 35. Root 2, right? And 8 over 7 minus 4 divided by 5, that is 12 over 35. Right? That's exactly what we were looking for, right, in the answer. Right. So you can combine them into 12 plus root 2 over 35. That's it. That's your answer. Alright, so moving on. Question number 9. Let f of x be this entire thing where a is a positive constant. Express f of x in partial fractions. Okay, alright. So this is first off an improper fraction, because this is x squared, this is also x squared. So first off we need to do the long division, right? So first off we do x plus 2a, x plus 3a. This would be x squared plus 3xa plus 2xa, that would be 5ax plus 6a squared. Right? So minor difference, but still a difference. So we have x squared plus 4ax plus 6a squared, and you have x squared plus 5ax plus 6a squared. Multiply this by 1, you get x squared plus 5ax plus 6a squared. When you subtract it, these two will get cancelled. You're only left with minus ax, right? So the f of x can be rewritten as 1 minus ax over x plus 2a x plus 3a. Okay, right, now I think we can do the partial fractions of basically this thing. So you have ax over x plus 2a x plus 3a. One would be like this x plus 2a x plus 3a b. So therefore, that one would be ax identical to a times by x plus 3a plus b times by x minus 2a. Right? Okay, so like we have two clear values. We can first start with x is equal to plus 2a minus 2a. So this one would become a times by minus 2a equals to, this one would remain only minus 2a plus 3a. The other one would 0. This transforms into minus 2a squared equals to 3a minus 2a, a small a. So 1 cancelled out. So a comes out to be minus 2a. Similarly, when you choose minus 3a, right? So this would also happen the same way. So minus 3a, right? And the first term would be 0. You'll be left with x minus 3a plus 2a. You'll have minus 3a squared identical to b times by minus a. Minus minus gets cancelled, a gets cancelled, so you are left with b is equal to 3a. Okay, so now f of x can be rewritten as 1 minus, we'll see the signs later on in a second. So x plus 2a was negative and this one was positive, so 3a over x plus 3a and minus 2a over x plus 2a. Now you multiply the minus inside, this will remain as it is, but this one will become positive. Alright, okay. Hence find the exact value of f of x from minus a to a f of x. Okay. Okay, alright, let's see that. So when we integrate this, so you have 1 minus 3a over x plus 3a plus 2a over x plus 2a dx, right, from minus a to a. So first one would be just x minus, this is the linear denominator, right? So this will be handled with ln x plus 3a plus 2a ln x plus 2a from minus a to a. Right. Okay, alright. So now we are plugging x as a, right? So a minus 3a ln a plus 3a plus 2a ln a plus 2a minus a minus 3a ln minus a plus 3a plus 2a ln minus a plus 2a. Okay, so this is something longer to remember. First, let's simplify this. You have a minus 3a ln 4a plus 2a ln 3a minus a minus 3a ln 2a plus 2a ln of a, right? Okay, we need to continue simplifying this, right? Okay, so you have a plus a, that is 2a. You can multiply the minus inside, right? So you have I'll just simply copy this. Okay, and right, this one would become positive, this one won't become negative, right? So now we can remove the brackets. Okay, so a plus a is 2a, and then you have 4a p plus ln q, a times by p plus ln q. Alright, I think we can separate out the ln 4a as ln 4 and ln a. So minus 3a ln 4 minus 3a ln a plus 2a ln 3 plus 2a ln a, then similarly 3a ln 2 plus 3a ln of a minus 2a ln a. Okay, so you see plus 2 ln a minus 2a ln a gets cancelled. Minus 3 ln a plus 3 ln a gets cancelled. What are we left with? Right, okay, so you have 2a minus 3a ln 4 plus 2a ln 3 plus 3a ln 2, right? ln 4 can be written as 2 ln 2, so we can write it as 6 ln 2, and alright, so let's factorize out a now. So 2 minus 6 ln 2 plus 2 ln 3 plus 3 ln 2. So minus 6 plus 3, that is going to be just simply minus 3 ln 2 plus 2 ln 3. Now we just need to combine them, right? So this would be 2 ln 3 is ln of 9, and 2 cubed is 8, So this one would be 2 minus, wait, P and Q are rational. P and Q are rational. Q is coming out to be rational, but wait, we'll see in a second. So ln 9 over 8, sorry, plus, right? Right. Right, so 2 would also be rational now, because you can write it as 2 over 1, so technically that's also rational. Right, so I think that's the final answer. Question number 10. The diagram shows a tank for holding water. The tank is in the shape of a cube of side 50 centimeter. At the time t seconds, the depth of the water is 8 centimeter. Water is poured into the tank at a rate of 5,000 centimeter cube per second. Water pours out of the tank through a hole at the bottom at a rate proportional to 8 squared. Okay. When h is equal to 20, the depth of the water is increasing at the rate of 0.4 centimeter per second. So if we write the volume dV over dt, it's been given as plus 5,000, like it's being increasing at a rate of this, but it's also decreasing at a rate proportional to this, so minus some k 8 squared. Okay, so v in terms of h, we have 50 times by 50 times by h, so 2500 h. So that means dV over dH is 2500, right? And we need to find out dH over dt. So dH over dt would be dH over dV times by dV over dt. Okay, so what else? dH, that would be 1 over 2500 times by 5000 minus k h squared. So 5000 minus 2500 is basically just oh, I think we can keep it like this now. So we can keep it like this. So 5000 minus k h squared over 2500. Now we have a specific value that when h is 20, dH over dt is 0.4, right? So dH over dt at h is equal to 20. So we will say that this is 5000 minus k, h squared would be 400 over 2500 equals to 0.4. So we just need to find out k, right? So 5000 minus 400k is going to be 25 times 2500 times by 0.4, which is 1000. So therefore 400k would be 5000 minus 1000, that is 4000. So k basically is 0.1 or 1 over 10. Right. No, no, no. Oh, no, 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 no. 10, 10, 10. 10. So, therefore, dH over dt is 5000 minus 10, h squared over 2500. So you can see that 10 is a common factor, so this can be factorized into 500 h squared to 250. That's it. That's all we had to show. Given that when h is equal to 0, when t is equal to 0, find the time taken for the depth of the water in the tank to reach 20 centimeter. Right, so first off, that means we need to integrate that. So so h would be the integral of this thing, 500 minus h squared over 250. Sorry, wait. We have to separate, no? We have to separate. So dH over dt is 500 minus h squared over 250. So when we like cross multiply and separate, this would be 1 over 500 minus h squared dH and 1 over 250 dt. You can like move 250 over there also, absolutely fine. Now this one is a quadratic factor, so we can just simply integrate this. Oh no, you have to do the partial fractions for this one, right? You have to do the partial fractions for this one. So, okay, so 1 over 500 minus h squared can be separated as, what is the square root of 500? Difference of squares basically, so 10 root 5 minus h plus 10 root 5 plus h. So this one would become so when h is 10 root 5, this, oh no, wait, sorry, wait. Actually, I should write over here. So 1 is equal to a times by 10 root 5 plus h, and b times by 10 root 5 minus h. Alright. So, right, okay. When h is 10 root 5, you get 1 equals to a 10 root 5 plus 10 root 5, so 20 root 5, 10 root 20 root 5. So therefore a is 1 over 20 root 5, which is basically doing 5 over 20 times by 5, square root 5 over that, right? Okay, similarly you have when h is equal to negative 10 root 5, this would be 1 equals to, then this one would be cancelled, this one would be left. So once again it will be plus, so b also the same thing, 20 root 5. So b would also be root 5 over 100. Under root 5 over 100. So 10 root 5 minus h plus root 5 over 100. 10 root 5 plus h equals to dh equals to 1 over 250 dt. Alright, now I think we can integrate. So when you have, like this is a coefficient over here, this does not bother us like that, so this is just a plain coefficient. However, when you have this, remember we'll take the ln now, but the derivative for minus h will be minus 1, so we have to multiply the minus over here, right? So this would be minus root 5 over 100 ln 10 root 5 minus h plus 5 root 100 ln 10 root 5 plus h equals to t over 250. Right? Anything? Plus c. Okay. It said that at when h is equal to 0, t is equal to 0. So when t is equal to 0, h is equal to 0. So at t is equal to 0, h is equal to 0. So this one would become minus root 5 over 100 ln 10 root 5 plus root 5 over 100 ln 10 root 5 equals to 0 plus c. So as you can see, they will both be cancelled out also. So c is also 0 therefore. So finally no, this is not the final 20 centimeter, right? So we just need at h is equal to 20 centimeter. So you have minus root ln 10 root 5 minus 20 plus root 5 over 100 ln 10 root 5 plus 20 times by complete 250 is your t. Okay, so alright, so let's calculate this. So you can simplify this one as root 5 over 100 ln of 10 root 5 plus 20 over 10 root 5, minus 20 and times by 250 equals to t. So we just need to plug it into the calculator because I don't think this can simplify like that. Square root 5 divided by 100. So I think we could have just simply done 2.5 times by that, right? Times by ln of 10 root 5 plus 20, then 10 square root 5 minus 20. So how many? 16.14 seconds. Since this is an inexact answer, we can just stick to 3 significant figures. That's it. Alright, okay, so moving on. Question number 11. Relative to the origin O, the position vectors of the points A, B, and C are this. Okay, the midpoint of AB is M,
as shown in the diagram. Find the vectors MB and MC. Okay, so first off, it's easy to find out the OM. That's going to be half of OA plus OB, because it's a midpoint of AB, right? So half of OA plus OB, 4 plus 2i, 6i, 8 minus 2, 6j, 4k, right? So 4 plus 2, 6, minus 2 plus 8, 6 also, and then plus 4k. This becomes 3i plus 3j plus 2k. So MB would be OB minus OM. So this is right. So 2i plus 8j plus 4k minus 3i minus 3j minus 2k. So this one would be minus I, 8 minus 3, 5j, and 4 minus 2, 2k. Right? And MC would be similarly OC minus OM minus 2i plus 6k minus 3i minus 3j minus 2k minus 5i minus 3j and 4k. Alright. Calculate the exact value of the cosine of the angle CMB. Cosine of the angle CMB. Okay, so we just need the value of the cosine of the CMB. So we can use the lengths of CB, CM, and BM for that, right? So length of CM or MC or MB, right? And the only thing we'd actually need, so we have CB, we'd also need CB, right? First we'll need CB also. Okay. So CB or BC, whatever that is. OB minus OC. So you have 2i plus 8j minus 2i plus 2i and then minus 6k. So you have 4i plus 8j minus 6k, right? Okay, right. Now MB mod first. So square root of 1 plus 25 plus 4, that is going to be equal to root 30 as it is. Now MC this is going to be 5 squared 25 plus 9 plus 16. 25 plus 9 plus 16, that is 5 root 2. Okay, now CB. (16
plus 64 plus 36 to root 29. So actually I think we should have kept them as squares. Alright, so if I remove the square, this is 116 and 5 root 2 50 and this would be just 30, right? Okay, so now we can use the scalar product, right? So scalar product between two sides, right? So CM and BM. So CM dot BM is equal to, or MC basically, either way, mod of MC mod of MB cosine of theta. Right, so first we need the actually we didn't need the CB, right? So you could use the cosine rule also technically. MC is this thing, so minus 5i minus 3j plus 4k dot MB is minus I plus 5j plus 2k equals to MC is 5 root 2 times by 2 root 30 cosine of theta. Okay, so minus 5 times by minus 1, just 5, minus 3 times by 5, 15, 4 times by 2, 8, equals to 5 times by root of 60 cos of theta. So minus 10 plus 8, 2. So minus 2 is equal to 5 root 60 cos of theta. So cos of theta would be minus 2 over 5 root 60. It would be better if we rationalize this, yeah? So let's see if we can rationalize this, so, or at least simplify that. So root of 60 is 2 times by 3 times by, wait. I think we can just simply plug it in over here. So 2 root 15, right? So 2 root 15. So this would mean that this is times by 2 root 15 root of 60. So this would be just simply minus 4 root 15 over 5 times by 60 is like 300. So 4 divided by 300, 1 over 75. So minus root 15 over 75. Right, okay, so that's the cos theta value. Okay. Hence or otherwise find the exact area of triangle ABC. ABC. Hence or otherwise find the exact area of triangle ABC. So since this is M is the midpoint, and we have one angle like this, the other like this. This MA would also be same length as MB. So we can find out using the sine rule or the area sine rule, right? So pi minus this thing. Oh, no, wait. Cosine is negative in the second quadrant, right? So if one is this, the other one would be just simply root 15 over 75. Okay, alright, so got it. Okay, so total area would be, you have BMBC, BM was, okay, like just to like clarify, I'm gonna do, okay, so BM root 30, so half of root 30, 5 root 2 times by cos of this value minus 15 over, what was it? Root 15 over 75. No, sine of that. Alright, so first we need the sine also. Okay, alright, hold on. So when we had the cos of the theta, cos value was root 15 and 75. Okay, so we need 75 squared minus 15, this thing. So this is root 5610. That's a very weird thing. Okay, now this divided by 75. Where did we make a mistake? Root 15 and this is 75. Okay, so we don't need this ratio, right? Because the ratio we already have. So 5610 root over 75 and then times by 2 because the values of the sine ratio and these two sides would be the same. So half times by 2 basically is just 1, and 30 times by 2 is 60. We can bring 25 inside, so 25 times by 60 times by 5610 whole under root divided by 75. So let's do it this way. You have 25 times by 60 times by square root. 25 times by 60 times by 5610 divided by 75. This is 2 root 374. Okay, and just to check if there is no other, yeah, alright, so there is no other part. That's the end of this paper. Now, I hope you enjoyed solving this paper with me. If you have any questions, confusions, or doubts, feel free to reach out through the comments. The number is also listed in the video and through the link tree also. So if you'd like some one-on-one coaching for May, June, or October-November 2026 exams, don't hesitate to call or text. And until the next video, take care. Bye-bye.